Yay, hello everyone. Welcome to another webinar offered by Discover the Universe. Thank you to everyone who's live with us right now. I see the names and where you're from being put in the chat right now. It's very interesting. Hi, Michael from Boston, and great to see so many familiar names, but also new ones as well. And thanks, if you're watching the recording, then thank you for being here as well. So for those of you who are live, if you have to go, it will be recorded and we'll send you the link to the recording. I'm also going to put the link that's on the slides right now. Here it is again. So if you want to access the content of the webinar, there will be many links in it. So I suggest you maybe don't click them all as I'm talking, because it's just going to be overwhelming to have so many tabs, but you have access to it. You can download the slides as PowerPoint or PDF, or you can create a copy. This one is not editable by everyone. Obviously, that would become a mess probably. But you can create a copy and then you can edit that copy if you'd like. So for those of you who don't know me, I'm Julie. I'm the director of Discover the Universe. And you've probably, if you've been to other webinars, you've probably seen me before. I'm the main educator as well. Tonight, we're going to be talking about teaching astronomy outdoors, how to take your classroom outside, do some activities, and just enjoy either the view outside or the larger space where you can create models and so on. So this has become, I think it's becoming a very popular ways of teaching to bring your students outside. And especially with the pandemic, kind of made sense to go outdoors and enjoy the fresh air over there. So for those of you who are live with me, feel free to put questions in the chat. I'm keeping an eye on that at the same time. And at the end, maybe once we stop the recording, if you want to talk, then I'll be able to give you access if you'd like to share some thoughts. But for those of you watching the recording, don't hesitate to write to me. I'm always happy to read comments or questions and so on afterwards. Okay, so if you are new to Discover the Universe, we've been around for over 10 years now, and our goal is to help teachers and educators by providing resources and training in astronomy. So our goal is really to help educators. We're a Canadian program. We do everything in both English and French. So the same webinar was actually offered earlier today in French. And most of what we do is online. Actually, for the last 2 years, it's been completely online. Usually we do a few in-person workshops per year, but of course we've stopped that in the last 2 years, and everything we do is free. I know we reach people in other countries as well. So because it's online and free, we're happy to see names and people from other places as well. So of course, you probably know about our website if you're here, but if you're watching the recording, maybe you haven't been to our website, so please check it out. We have some resources there, and we actually have a lot of resources in the background right now that will be appearing online very soon. So make sure you register, make sure you sign up to our newsletter if you like to know what's coming. And you can also follow us on social media. We're on Facebook and Twitter in both English and French. So if you want to learn more about astronomy in general, little news that we share, little bits of information about Canadian astronomers and so on, make sure you follow us. So today, teaching astronomy outdoors, I'm going to present many activities we've done in the past. Some of them are online, some of them are still in the background, but I'll give you the links to stuff that's being developed right now if it's not live yet. And some ideas we've shared with some teachers, or we've had a chance to test with teachers as well, that it seemed very useful. So why take your kids outside, right? Why do activities outdoors? Well, I just want to share some background research, and if you need to convince your peers or your principals and so on that this is worth doing, it might be a bit intimidating at first, but there's a lot of studies being done now, and I've actually had the chance to collaborate with Jean-Philippe, who's a professor in the Faculty of Education, not too far from where I live at the Université de Sherbrooke, and I know in Quebec at least, has become sort of a leader in outdoors education. And there's a link there if you want to go see. That's actually a research article. They've done a meta-analysis of other articles that kind of highlight the benefits of going outdoors with your students. And I just wanted to highlight a few points here. Definitely when it comes to astronomy, if you want to observe the sky, for example, it makes it a lot more authentic to go and see the real thing than learning in your textbooks. And not just in astronomy, but also in different fields. Obviously, if you want to study the trees or just the environment, it makes a lot more sense to go outside and do the real thing. It helps contextualize, obviously, certain concepts, make it a lot more concrete for the students. In terms of knowledge retention, it's been proven that it helps a lot as well. So a lot of it has to do with how students learn, and it makes it better for them to learn and really understand the concepts. But it's also a lot more fun for many students, right? The motivation and the enjoyment of being outdoors, doing something different, being out there, learning in the field is probably a lot more encouraging for many students. And that probably helps with the knowledge retention afterwards. And I love that it helps develop students' competencies as young scientists. When you're outside, a lot of the activities I'm going to tell you about have to do with observing the environment, observing the sky, taking notes, can ask questions, when you try to find the answers as you're observing. So that's really, those are all competencies that help you as a scientist. So really your students can be young scientists and doing the real thing outside. So become doing astronomy as astronomers and be outside observing the sky. And Jean-Philippe has also written an article on the EdCan website. So again, you'll have the link here, but 5 tips to help you get started in outdoors teaching. So just very broadly, like how and you do it. There are some tips there, and maybe plan short activities at first because it's kind of harder to manage your class once you're outside. Make sure you make connections between regular and outside and inside afterwards, and just have fun with it. I would say, like, try something and have fun with it with your students. But I'll let you read the whole article there. That's why I put the link there. And again, you can access it. All the links are on the slides. If you're just joining us, the slides will be provided afterwards. And I'll just put, because we don't see the chat from before we join, I'm just putting it again in the chat. Okay, so exactly how do we do it in astronomy? You might think, astronomy, kind of looking at the night sky. I've got my kids in the daytime. How do I do it? How do I reconcile all that? The 2 main things I'm going to talk to you about are observing the sky. Even during the day, there's a lot you can do to understand the motions of the Earth, observe the moon in the daytime, and so on. So observing the sky is definitely one part. And the second aspect will be creating models, using the space that you have outside to create models. And for example, if you want to do a scale model of the solar system, you need to go outdoors because the classroom is not big enough. So that will be the second part of it. So observing the sky. This is a module that some of you might be aware, might know already, because it's been on our website for a few years. It's called Looking Up. I actually wrote this in 2016, if I remember right. So before the pandemic, before it became more of a trend to bring your students outside, although I guess it depends where you are, but it seems like it's that way here in Quebec anyway, that's becoming more popular. But my goal with this was really to reconnect teachers and their students to the sky, and not just the night sky, but just think about looking up. Every time you have a few minutes when you go outside, look up and just pay attention to what you see. Obviously, you'll learn about the weather at the same time, but you'll also see, you might see the moon in the daytime. And this is actually something that many people are not familiar with. They don't think that we tend to associate the moon with nighttime, but it is up there in the daytime, and it's worth paying attention to that as well. So this guide, again, it's in the resources section on our website. You can download the PDF, the whole thing, or either section by section. And it has 8 activities, which can be adapted to different levels. Most of it, I would say, connects to the curriculum across Canada, mostly in grade 6 or elementary schools or middle schools a little bit. But to be honest, it can be adapted to many different levels. I taught college astronomy, and I use some of the activities in there. It just depends on how much you want them to record their observations or how far you want to go in the discussion and so on. But really just looking up and taking notes, that applies to all levels. So you can do that, with grade 1s, or you can do it at university level as well. I wanted to make sure you didn't need any equipment, so you don't need telescopes or anything like that. Just your eyes really, and of course, pencil and things to take note. And the main topics are about the moon, the sun, and stars. However, with the sun, it's really about the Earth's motion. So when we talk about how the sun, like how long is your shadow, for example, where is the sun in the sky, and how it varies throughout the day or throughout the year, that's actually related to the motion of the Earth, how the Earth rotates and how it goes around the sun, for example. So I put the sun because that's sort of what we're observing, but that kind of relates to topics in your curriculum that are linked to the Earth. So I'm just going to tell you a few of them here. And of course, you can go online and look at the whole resource. So here's an overview of the activities. Again, you can see the titles and the grades. Many of them are 4 and up because they can be done at higher levels very easily if you adapt a little bit. And you can see the subject. So the sky, the first one is general, and then the moon, the sun, and the stars. Today, I won't be talking about the ones that are about the stars because that's more something to do at night. You can invite your students to do in the evening at home, or if you have an evening activity at school, you might want to look into that. Although the introduction to the star finder, that can be done during the day, but it's not something that would be super easy to do outside. So I didn't bring that today. But Globe at Night is also a very interesting activity to learn about light pollution and how dark your sky really is. And that would be interesting for students to do that and compare with other places around the world, for example, how dark the sky really is and how many stars you can actually see. So activity 1, which is simple, it's called In the Sky, I Can See. It's very simple, but very effective. And actually, I've done it inside as well. You don't need to do it outside, but of course you can bring your students outside, especially younger ones. And then you ask them to draw everything they can see in the sky right now, like during the day. That would be the first space here. And then you ask them to draw what they can see at night and let them do it for a while and then share their ideas. And it will be very interesting and very rich what they come up with. And just even the idea of what's the sky, right? Because young kids will put like birds or anything they see when they look up. And then you can have a discussion as well, like what is the sky? Like I tend to think of the sky as things very far away, like outside the Earth's atmosphere. But of course, some things are much closer to us, but we still see them when we look up. So that could be a very interesting discussion. And what they can see at night, again, they might not be aware that they can see planets in the sky. They might say stars, the moon, because they might be more familiar with that. But then you can really bring different, some students might know more, like, shooting stars or comets once in a while, not that often, but once in a while. So it's very simple. I've done it with adults at teacher training events, and it's always interesting. There's always a lot of discussion that comes from just a simple activity like this. But going outside and doing it under the real sky could actually be interesting. Hopefully it won't be completely cloudy, so you can see a few things beyond the clouds, but hey, you never know. It might be cloudy too when you do it. So activity 2 is about the moon. So observing the moon as often as you can over a full lunar cycle, so about 30 days, is always very interesting. You don't even need to fully explain the phases of the moon for students to really learn about how it changes. So if the first step, depending on the level of your students, if the first step is just for them to be aware of the different phases and how it changes, how it goes from one to the other, if they've never paid attention to that, then it can be very interesting for them to observe the moon as often as they can, or in the month, for example. And you could remind them, try to do that today. It's nice out, and try to see if there's a moon. Or you could take the students outside when the moon is visible in the daytime. And of course, it might be tricky for you at first to know when is the moon visible in the daytime. I didn't think about adding it here, but programs like, hold on, I'm just gonna get a website for you. If you know about Stellarium, I really like, there we go. I really like, Stellarium Web, which I just put in the link, but I'll make sure to include in the email to everyone. Stellarium Web, you can go there, and if you tell it where you are located, well, actually, hold on, let's try that. Can you all see Stellarium on my screen, or is it still showing the last page? Those of you who are online with me, hopefully you can see Stellarium right now. Can someone confirm in the chat? Yes, perfect. Thank you, Ed. I just wasn't sure if I was sharing the tab or my whole window. So Stellarium Web is an amazing resource where you can go, and it should be able to say where it's located. For some reason, for me, it defaults to near. Actually, that's not exactly where I am, but close enough. I don't know why it's called near, but anyway, and then it will show you the sky. This is tonight, actually. It's not exactly now, but I could pick, a date and a time, and then you can see if I look west, for example. Actually, I'm going to go in a few days. The moon will start appearing in the evening sky. So this is on the 4th of April. In the evening on the west, you will see a beautiful crescent moon. There you go. So you might not know about stellarium, but you're probably already seeing the power it has, like the potential, that how much you can do with it. You can zoom in, you can move around, see different locations in the sky. You can change the time to see the sky at different times. So I could go and check, for example, during the day, on the 6th, hold on, I'll go backwards in time. And I will have a moon there during the day. So I could go out and observe the moon during the day. Well, this is next Monday, for example. So you could use stellarium to find out when things are visible in the sky, when the moon is visible during the day, and then take your students outside with you to observe the moon in the daytime, for example, and take notes of it. I see some other suggestions there. Yeah, timeanddate.com is also very good. That's true, because it offers moonrise time and set times for different locations. So that's a good resource. Thank you, Linda. The moon calendar given by Google Calendar, and check for dates near the new moon. If you want to see that the moon, actually, for example, if you want to observe the moon in the evening, then you can start a few days after a new moon. So any calendar basically now will give you, can give you the phase of the moon now. So you know when next new moon is, for example, you can check that in a calendar. So very good tips being shared. Thank you. And this way you can find a little bit more about the phase. But if you're still confused, and that's completely understandable, because I was not very good at that at first. Like, okay, if it's first quarter, when is the moon visible? Then you could always play with stellarium and become familiar with that. And there are ways eventually to fully understand phase of the moon and to know when it will be in the sky, but that's another level. And that was not part of what I intended to talk about today. But I just wanted to show you Stellarium Web because it's an amazing tool. Please play with it, and it's fun. You can show your students as well. And it's a great way to know when the moon is visible in the daytime, or for a specific day, for example, you can go and check what will be up there in the sky in the evening or during the day. But coming back here, yes. So again, if you want to observe the moon over a full lunar cycle, you could definitely try to do it a few times with your students during the day. Take them outside. And you don't need to go out for half an hour, even just 10, 15 minutes. They see it, they draw, they note their observations. And a moon observation journal, this is one format that I put in the module looking up. But if you look online, if you look for moon journal, you'll see different ways you could have it. And it doesn't really matter which one you use. In a sense, it's just a way for you to record your observations. And log books like that are used by scientists when they make observations, whether in astronomy, when they make observations, usually associated with pictures now, like real pictures of the sky instead of drawings. But even with drawings, for example, in different fields, like people will still take notes and record what they've observed or what they saw or things they've noticed, for example, in a logbook. So I highly recommend you try that. This is really acting like scientists. And just use whatever journal, whether this one or another one. And it will be interesting for students to see patterns, how it changes night after night, when they saw it in the sky, what time, where was it, and they'll see how it changes day after day. Of course, you won't get to observe it every day because clouds will be in the way, but it's okay. You don't need to observe it every day. Like hopefully, like for us here, the last few weeks have been really bad for observing the sky. So hopefully you would get a month where you have at least a few clear days and nights. But you don't need to have every night clear, obviously, to notice the patterns there. However, if you don't want to do it over a full month, you could start with the evening moon, which is sort of a simpler version of a moon calendar in a sense. The evening moon is when you start observing a few days after new moon. So actually for us, new moon is on Friday, on April 1st. And then so early next week, we're going to start seeing the crescent moon in the western sky after sunset, like I just showed you in Stellarium. And if you observe night after night, or again, hopefully a few nights in the following 2 weeks, then you'll see the moon change night after night. So it will go from a very thin crescent low on the western horizon to a thicker crescent higher up in the sky and towards the south and then towards the east. And then 2 weeks after new moon, you would have a full moon rising in the east as the sun sets. So that's over 2 weeks. Of course, you could need support from the families because this will be done mostly after sunset or as the sun sets, so in the evening. But it will be interesting for students to see patterns. I've actually done it with my kids before, and we drew, for example, in front of our house, we drew like the trees that we could see, and make sure we made each observation from the same spot. And after 2 nights, they were able to predict where the moon would be on the next night, because they could see how it moved across the sky, how it got bigger, and then they can make predictions for where it will be the next day, and then they can go and observe again. So this is very interesting. I remember with the first few times I actually did that myself, or noticed how the moon changes in the evening, night after night. And it's very interesting to do this by yourself, like even for yourself, like to understand the phases of the moon. It helps to see it grow night after night in the western sky. So I highly recommend it. Evening moon, if you want to start that. And again, this doesn't have, it's sort of a simpler version of the moon journal. It's just over 2 weeks in the evening, but there are different ways to do it. Another activity, and this is something you can definitely do with your students, is the daytime moon, is going outside when the moon is there and try to reproduce the moon that you're seeing in the sky. So for this, I highly recommend little styrofoam balls that you find in dollar stores. I don't particularly like using a lot of styrofoam. It's not the most environmentally friendly material, but hopefully you can reuse them a lot. But what I like about these balls is the way they reflect the light. So it doesn't work super well with very like glossy balls. If you take them outside, or like rubber balls, they don't always work well for this. But if I were outside and if I see the moon in the sky, a bit like the drawing there, and if I hold my moon, so this represents the model of my moon, if I hold it under the real moon in the sky, I will see the same phase on my ball as I see on the moon. So the way you see it here on this drawing, there's a crescent moon here, and you can see that the ball is lit with exactly the same phase. And that's how you realize that, wait, the moon is always a sphere, but you only see one side of it is lit. And that's what we see from Earth. But I actually did that with my college students, so 17 years old and above, and I took them outside during the elective astronomy course when I was teaching in Cégep here in Quebec. And it was an aha moment for them to look at the moon and kind of, now I get it, right? I have the moon in front of me. I see the part that's lit. Okay, that's how phases of the moon work. The moon is always a sphere. For some reason, that's not clear for everyone. It makes sense because it almost looks like part of it is missing. And so many things in our pop culture kind of shows either that we see through the part that's missing, like we can see stars in the background where the moon should be, or I always forget which movie company it is that you have the little guy fishing, sitting on the side of the moon as if you could actually sit there when it's just a part that's lit and not lit by the sun. So holding it like this, holding your moon and seeing the part that's lit really helps you understand the phase of the moon. So again, it's an activity when you know the moon is up in the daytime, use Stellarium to find those little balls. Maybe try it for yourself first, but then take your students outside and see how that helps them visualize the phase of the moon. So that's a very good activity. Thank you, Linda, for the comment. Yeah, I really like it. I really like going outside because then you really see the sun, the real moon, your moon ball, and then you kind of make the connections there. Of course, you can do for the phase of the moon activity inside with an artificial light, and I still recommend it. I still like it, but there's something a bit different about taking your students outside and doing it with the real sun. I agree. And one thing I love about this activity, and maybe that's like the nerd in me that really likes making connections and being able to understand everything that way. I know for me, again, to understand the phases of the moon, I guess I'll explain it this way. To understand the phases of the moon, you really need to understand the world in 3D. Like your spatial visualization, you need to hold on, I'm kind of missing the expression here, but you need to practice visualizing in 3D, and it's not given right away. So even for you, if phases of the moon are still a bit confusing because you have a hard time visualizing everything, it's perfectly normal. And this activity helped me personally many years ago become very familiar with how the phases of the moon work and visualize how things change, and being able to visualize in 3D and easily understand when the moon will be visible at what time, for example, or which phase would be visible when. So the trick here, if you're outside, again, during the day, if you see the sun and the moon, point to both with your arms, like the little girl is doing on the left side of the drawing, like the A side. Again, this is a drawing from the module, so you can go online and you'll see it in our module looking up. But if you're pointing to both, then the angle between your arms can tell you a lot about the phase that you're observing. So this is like the nerdy part that you make connections with math. So the girl there, the way she's pointing, it's 90 degrees between her two arms. When it's 90-degree angle between the sun and the moon, then you know for sure it will be a quarter moon. If it's an acute angle, if it's less than 90 degrees, it will be a crescent moon. If it's more than 90 degrees, it will be a gibbous moon. Now, if you're not familiar with gibbous moon, that's the term we give it when it's between quarter and full. So bigger than a quarter, but less than full. And then if it's 180, that will be a full moon. So that's kind of fun to do the connection with the angles here. But what I like, and one point I always mention in astronomy, is that it's hard to reconcile your view of the sky. So what you see when you look up with the drawings that we see in textbooks and online, for example, the drawing that we see on the right here, the B drawing, where you see, the celestial bodies and how they relate with one another. So here you see the sun, the moon, the earth, and how they relate to one another. But how do you go from what you see in the sky to the view from above? Well, this helps because the angle that you have, let's see here, it was 90 degrees. Then you could go inside, draw the sun, draw the earth, and then the moon will be at an angle of 90 degrees. So the angle will be the same. And again, if it's an acute angle, roughly, then you know that the moon, for example, instead of being here, would be here. Now, this is obviously not to scale. The sun would have to be very, very far away on this drawing for it to make sense, because the way it's lit here, the sun would have to be extremely far away. But I love working with the angles like this. And for older students, it might be fun to say, hey, we're going outside, look at the moon, look at the sun, and then come inside and draw the Earth, Moon, Sun system where the moon should be today if you were observing it from above. That would be a great way for them to make the connections between the two. And then you could do it many times in the lunar cycle and see how it changes. And at some point you get so used to it that when you see the moon in the sky, you can point to where the sun should be, even if it's below the horizon. And that's when you realize, okay, I get a good understanding of phases of the moon because I can't even point where the sun should be below the horizon. But try it out, try it for yourself to fully understand the concept, and then try it with your students if they're old enough to go with that concept. But it's, for me, it helped a lot anyway, so I wanted to mention that. I hope that makes sense. Not that easy to do with my webcam here, and I don't see your faces to see if you're all confused with that idea, if it makes sense. But anyway, let me know if you have questions. Another activity we could do with the sun, of course, you don't want to stare at the sun, but you can observe the shadows, for example, to see a bit how the position of the sun changes in the sky over the course of a day or the year. And an activity we wrote down was just how long is my shadow? So you could go outside. If you do it during a day, you could try to do it many times during the day and see how morning to noon to evening, or when they leave school in the afternoon, how much does the length of the shadow changes during the day. And it could be interesting first to have them predict how it's going to change, and then they go outside and they make a few measurements during the day, and then they try to explain it, because of course the sun rises in the east and sets in the west, and it's at its highest point around noon, although 1 p.m. when it's daylight saving, but even then it varies a little bit depending on where you are in the time zone. But all that is due to the Earth's rotation, going from east to west. So that could be a good introduction to, wait, your shadow is connected to how high the sun is, and of course it's going to be lower on the horizon earlier in the day or later in the day than around noon or 1 p.m. or middle of the day, I would say. Now you could even try this over the course of a year. Let's say you pick a time and you decide, we're going to measure the shadows at different times around noon. Again, if you wanted to do this over the course of a year, you have to consider a few things like daylight saving times and how local noon changes. But let's say you do it roughly around noon, and then you see how much that varies over the course of a year, because the sun will be much lower in the winter than it is in the summer, or different times, fall and spring, for example, that will vary. If you do that, though, I suggest you don't take a student as your measuring pole, because students grow over the course of a year, so that might affect your measurements. But you could just take a stick and measure it a few times a year, for example, and that could be interesting as well to discuss how the sun is much higher in the summer than it is in winter. Or you can make, there are many different variations on this. This is just a simple idea of measuring your shadow over the course of a day. But if you want to dig further into that, if you are interested, email me and I'll send you a few connections on how, to take this step much further if you are interested in this with your students. And in fact, one way to push this further is actually what we call the ERATOSTHENES experiment. So basically it's repeating what the early Greek mathematician or geographer or whatever, it was a bit of everything, astronomer, did over 2000 years ago, which was to calculate the size of the Earth with the measurement of a shadow. And I knew about Eratosthenes' experiment from a long time ago, but when I actually got to do it, and you end up with the measurement for a calculation for the size of the Earth, the size of the diameter of the Earth, that's actually pretty close to what the real value is. It's quite amazing, because all you did was measure the shadow of a stick, compare it with the shadow of another stick somewhere else on Earth at the same time, and there are ways to do that. And there you go, you can measure the size of the Earth with that. So it's actually quite an amazing experiment. I highly recommend it. We've been promoting it for a few years, and we actually have a webinar that's available in our archives. It's called Measure the Earth with Your Students. So if you want to have the whole description of it, and the historical aspect and how you can do it with your students and the reasoning behind it for the calculations and everything, you can go ahead and visit the archives on our website. But there is a fantastic international campaign that's done every year for many years now on the equinoxes. So March 21st, so it just happened last week. And the next one will be September 22nd, roughly. So you could check their website, see when this is something you could plan right away for next year. For example, if you want to do it in September or March, and there you can share your measurement with another school somewhere else in the world. When I actually did it, part of the campaign, I ended up sharing my value with a school in Colombia, I believe, if I remember well. Anyway, I had to use Google Translate because my Spanish is not that good, but we're able to write emails to one another, share our value, and using both values, we each got a measurement for the size of the Earth, which is quite fantastic. But the measurement itself is going outside and measuring the shadow of a stick. So that's done outside as well. But if you want to learn more about it, about the Eratosthenes experiment, again, you can watch our webinar or go to this website here. And of course, if you're joining again, the slides will be shared, so you will have access to all the links that I put in there. Okay, so other activities you can do outside. This is one we started 2 years ago over Christmas, over the winter break, and it proved to be very popular. So we're going to be offering it again every November, December. So this year we did it end of November through mid-January, roughly. It's a challenge to discover things in the sky. And this year we linked, we kind of built it with as a partnership with the Institute for Research on Exoplanets in Montreal. So of course, exoplanets are planets around other stars very far away. You don't see the exoplanets directly, but it's kind of fun to look in the direction and say, hey, this star most likely has planets around it, or we've discovered a planet around that star. We know now that most stars that we see at night most likely have planets around them, but it's kind of fun to point to one that you know that for sure. So we try to bring connections with exoplanets in there, because that's always a fascinating topics for students. Like, is there life somewhere else? Are there other planets like the Earth somewhere else? So bring connections with exoplanets. But what you can see in the sky, so this was the sort of bingo sheet that we had this year, 9 observations with 2 bonus observations. Observe the moon in different phases. You might not be able to read it directly, but there was observe Orion, the Pleiades, like specific things in the sky that are relatively easy to see. We try to think about kids both in rural areas with dark skies or in the middle of the city. Actually, my colleague who built that lives in the middle of Montreal, so her sky is quite different from mine. And we try to find things that are easily visible, or maybe not that easy in a city, but visible for everyone. Last year we had Jupiter, Venus, and Saturn in the sky, so that was like a great view. And we provided a lot of information. And again, I put the link to the last edition because you can see a bit what we did and plan for this if you want to do it with your students and invite them to look up. Again, that takes them outside in the evening for some of it, although we do highlight a few things that are visible during the day. I believe we had the last quarter moon in there visible during the day. And what we shared with people were, well, you might recognize this as a screenshot sort of of Stellarium, actually highlighting when the moon will be in the sky compared to the planets, or constellation of Orion. And we had different texts. So the background information on how that relates to exoplanets or what it is exactly, a star nursery, for example, in Orion. So we had little text that your students could read and learn more about all these objects. So we're trying to add more background information on the science behind what you observe in the sky. And we had videos as well. So this is my colleague, Marie-Ève from IREX in Montreal from the Institute for Research on Exoplanets. And we had videos as well. So this is becoming a very popular activity, our observational challenges, and we'll repeat it. Our goal is to repeat every, November through January for every year in the coming year. So the bingo sheet will be adapted every year for the sky that year. And why do we do it at that time of the year? It's cold, we know. It might not be the best skies depending on where you are in Canada. Where I live, it tends to be very cold, but quite nice skies sometimes in the winter. However, it gets dark very early. So it might be a lot easier for many families to be able to observe any time from when you pick them at school, all the, when they come back from schools, all the way until they go to bed. And part of it can be done, even a bit later over the holiday break. If they stay up a bit later, they want to do some of the observations with their families, for example, they could do that. So we'll try that again next year. But again, the link will be there if you want to see a bit what was done last December. Now, for the second part, I want to talk about how you can create models outside. So take your students outside, not so much to observe the sky, but use the space that you have there and have them move around and create models. So one that's very popular, and we didn't invent that. It's not something we invented. It's just like, it's kind of a very common activity, is to model the solar system in your neighborhood. It's impossible to represent the solar system on a drawing like this, the one I put there, and it's not because the European Space Agency, ESA, is not good at making drawings, but it's not to scale. There's no way you could represent the planets and the orbits to scale on a slide or on a sheet of paper, just because if you respect the distances, then the planets will be invisible, they'll be too small. And if you respect the sizes, then it won't fit on that size. So the best way to do it is to create a scale model. And then if you want to be able to see your planets, it needs to be big because you'll need to move and it will have to be outside the classroom. Otherwise the planets will be invisible, they'll be too small. And we've done it with many groups, and it seems, for everyone, even just earlier today in the French webinar, a teacher was saying that she did that with her students, and even for herself, she knew the solar system was big, but she didn't realize how big it was until you actually do this activity. So on our website, we have a link where you can measure, like you choose the scale that you want for your solar system. So you decide how big you want the sun to be, and it will tell you the size of the other objects. It will even give you some example of objects like chickpeas, for example, or popcorn kernel or things like that, and how far it would need to be, how far you need to travel to put that object. And what's interesting, so if you start, for example, with a basketball with the sun, then you'll have little nuts and pinheads and like very small things for the other planets. And you can put the map of the solar system with the school in the center. So this is something I did for a school nearby here. And you can see the orbits of the planets, like the purple one here was Uranus, and you can see a bit how far they are. Now, seeing it on a map is one thing, walking it is another one. So it's kind of interesting if you go for a walk outside with your students and you put the objects in different places. And this is what a school shared with us. And it's kind of funny because she's put, the kids have big smiles with the emojis on front of their faces. But it was interesting because they said they lost Mercury twice, I think, just because the object was so small that on the way back, they couldn't see it. So they lost it twice, but it seems like the classroom everyone had a lot of fun doing this. And it was kind of mind blowing to realize how big the solar system is. So a good way to go for a walk, if you pick the basketball for the sun, then if I remember right, Neptune is about 1 kilometer away. So you have to plan accordingly. I think that school couldn't get to Neptune just because of the space on the street that they had and even the time. So you have to think about that. But it's interesting to do it. And it's really mind blowing to see how big the solar system really is. Now, if you don't want to do the whole solar system, even just going outside with a few balls, or depending on how many people you have, globes or different ways to represent the Earth, and have them do the Earth Moon model. I have a smaller version here. For example, if this is the Earth, this is 2.5 centimeters or 1 inch across. And my friend just mentioned that I've never tried it, but I really like the idea. And she says when she does that with students, if she has, these are actually, this one is from a kit, but you can buy a bit like that styrofoam ball. You can buy different sizes of those balls, like they're craft material in dollar stores, and some of them are exactly one inch across. So she had many of those styrofoam balls for the Earth, and they, like, the kids would have time to like color it or make it look like the Earth. And then she had Play-Doh, and she asked the students, like, how big do you think the moon should be if this is the Earth? And have them create like little balls in Play-Doh. And it was interesting to see first their thought about how big it is. Now I have the answer here, but then you can ask them, like, how far away should it be? And of course, this is a small model you could do in the classroom. But if you were outside with bigger balls, for example, or just like a globe and a smaller, like a tennis, if you're a standard globe with the moon is pretty much a tennis ball. This is actually the kind of ball that goes in a dryer. You might know what I'm talking about, but that's about the right size with a globe. Then ask the students, like, how far should it be? And it's always further away than you think. You tend to imagine, like, you know, that maybe that far, but on this model here, it wouldn't even fit in my webcam because it would be about 75 centimeters apart. So that's actually, usually it's further out than you think. And the activity that I'm linking here makes you create the model, but also think about, well, where is the International Space Station? So again, this is probably something you could do in the classroom because it's about the size. If I remember right, you need to put the moon about 9 meters away. So you could probably fit in the classroom, but, you know, if you had a few teams outside doing it, then you could use a larger space in the schoolyard, for example, and have them put where the moon is, and then think about where's the International Space Station. This activity goes even further to think about how thick would the atmosphere be and how much water is there on Earth on this model. So just think about the limited resources we have on our planet. When we shrink it down to the size of a standard globe, we realize there's not that much water in it. Which I see the question there, what grades do you think this would be good for? To be honest, it depends if you want to do it as a demo. I think as a demo, I would go any grade. I think this even when I've done it with adults, they found it impressive to understand the distances. But if you want the students to do it themselves, then they might need to be probably like grade 6 and above, I would say, because it might be harder to do it, to have them do it lower grades. But it's still very interesting to, even as a demo, I think it's very interesting for all grades. Yeah, like Linda says, all ages would be impressed by this activity for sure. And I just realized that I didn't even put it in my slides. I might add it, actually. I might add an extra slide for when I share it. But just going outside and have students act as, you know, have some students be the Earth, have some students be the moon, and then the sun, and have them move around. Like, you know, you have the moon go around the Earth spins on itself, and then everything moves around the sun. You need a lot of space to do that. So being in the schoolyard is perfect. And it gets a bit messy, like with everyone moving around, but if they take some time to think about it, at some point it makes it very relevant for them to spend time moving and doing the models, like the kinetic model of how things move in the solar system, either just the Earth and the moon, or you could even create a human orrery, right, with everyone being a planet around the sun. That's another scale. I won't go into that. Like, I don't recommend that for everyone because that's really another scale when you have so many people move around the sun. But it would be interesting to try that as well if you wanted to use the space outside to create models of different things in the solar system. And one thing I really like is to model eclipses. I'm fond of activities like that to play with shadows. And that's what eclipses are, shadows. So these are not my pictures. They're from the link that's there, NICE network. And I love, you know, how they just say, hey, you know, gets to your students outside, either a globe. This is the Earth ball. I really like the Earth ball. If you do a Google search for it, it's just a, you know, blow up ball of the Earth that you can use. And I always have one with me when I do workshops because it's very easy to, you know, to put in my suitcase when I go somewhere. But, you know, if you have a globe or the Earth ball outside, or any ball really that you know, act as the Earth, and then a smaller ball for the moon, then if you have the real sun, then you can try to create eclipses. So the little boy here is creating a solar eclipse on the Earth ball and understanding that, you know, the moon is blocking the light from the sun, so it creates a shadow on the Earth. Now, this is not to scale, so it could be interesting just to understand shadows. If you want to do it to scale, that's where this other activity comes in, which is my all-time favorite to explain eclipses. So the little Earth and moon I had here, if you put them 75 centimeters apart on a ruler, and here you have the material to do it, it's pretty simple. You just stick them, if you have styrofoam balls or Play-Doh, you just stick them on a paper clip that you unwind and you tape them to the meter ruler. So like for $2, basically you have all your equipment, and you have the scale model of the Earth and the moon on a stick. And then if you go outside with the real sun, you try to create eclipses, and then you realize it's very hard to align the moon and the Earth to create like a solar eclipse, for example, is the hardest, because the moon is very small and it's quite far away from your moon, and the alignment has to be just perfect. And that's how you realize, like, especially if you talk about phases of the moon, usually the question comes like, why don't we have eclipses every month? And then you realize the alignment has to be just perfect, and it's not that easy to create eclipses. Actually, that's why they only happen every 6 months or so, somewhere on Earth. Like in one location, it's not once every 6 months, but there are eclipses once every 6 months somewhere on Earth. But even then, it's not every month because the alignment has to be perfect. This is the material to do it, but if you want a kit, again, this is from the Astronomical Society of the Pacific. So they made kits that are foldable, which are, again, very useful when you travel and do workshops in different places. So I really like that. I put the link there if you want to buy the kits that are already made, but again, it's very easy to create your own with the material that's there. And again, you'll have access to all of this. And this is, again, a picture of, it looks almost like from this perspective that the two balls are the same size, but they're not. It's just like we're seeing the moon from much closer here. And people are trying to align it with the sun. And once you get it here, this is a solar eclipse happening on this Earth with a shadow of the moon right here. And I put here a link to more info on modeling eclipses. This is a PowerPoint that I had created many years ago that offers more information on this activity. So again, feel free to download it once you have access to this slide. So doing this outside, either with balls that are not necessarily to scale, is still useful to talk about shadows and how things work. And then, of course, if you can have the model to scale, probably with older kids or grade 6 and above, you realize it's really hard to make eclipses. Basically, that's the point of this activity, but it's kind of fun to realize that. And, you don't have to, I'm talking mostly about teachers in the classroom, but of course, if you're an after-school program educator or working in a science museum, that's the kind of quick activity you can do as well with groups. Take them outside. Of course, it needs to be sunny if you want to use the sun. If you can do it inside with a light as well, but this is the whole goal, is to take your students outside here. And we're going to be talking about eclipses a lot in the coming years, because there's two nice eclipses coming in Canada in the next few years, especially the one in 2024. So we're almost 2 years away. But first, October 14th, 2023, there will be an annular solar eclipse in the United States. So where it's red here is where the eclipse will be at its best. Canada gets none of the annularity, but we do get a partial eclipse visible everywhere in Canada, although much better on the West Coast. I think about 80% of the sun will be covered, if I remember right. So if you're on the, the Western provinces, this will be a great show, October 14th. And then 6 months later or so, April 8th, 2024, it's a total solar eclipse. So that's extremely rare in one location. I happen to be exactly in the path of totality where I live, so I'm very excited with that. But again, where it's red is when the moon will cover the sun completely. And in one location, it's extremely rare. This is the only time in my lifetime that it will happen above my house, unless I move. And, anyway, you understand the idea. But this is the only time it will happen here. And actually, I think the last time it was total over highly populated, like densely populated area in Canada was in 1979. I think there was another one early 2000, but over northern parts where, there might have been obviously some communities, but not a lot of population. So this one will be big. Because it will be a lot in the media. It may be 2 years away, but a lot of us are already working to organize things for this total solar eclipse, because it is really a once-in-a-lifetime opportunity. So if you are, it crosses like Southern Ontario, Southern Quebec, New Brunswick, Prince Edward Island, a little bit of Nova Scotia, top of Cape Breton, and then through Newfoundland as well. So if you are in those provinces, for sure, we will be talking a lot about it. And it's going to be in the States, in the United States as well. So it will be in the media a lot. If some of you remember the 2017 solar eclipse, totality was only in the United States, but it was big in Canada as well, in the sense that the media picked it up. And I know many people who organize activities, for example, in Montreal, and they ran out of glasses very quickly because everyone heard about it. They went to observe it and so on. So this one will be total in Canada. So I can only imagine in 2 years, everyone will know about it. Not yet, but it will be. The astronomy community is already getting organized, but it will be big in 2 years. So I wanted to mention eclipses. And actually, it's going to be on a Monday afternoon. So classrooms will definitely, hopefully it's going to be clear. That's, what we want. But we'll be working with schools a lot, because at least for Ontario and Quebec, it will happen during school hours. I think for the Atlantic region, it's more afterwards. And yes, we need to think about how to get eclipse glasses, because of course, to observe eclipses, you need to have eclipse glasses, which are not the same as solar glasses. They need, this is extremely opaque. So right now, actually, when I look through it, I don't see anything. This is just a rectangle, but this is the shape of glasses. And these are great. Of course, you need those to observe the eclipse. So yes, the Royal Astronomical Society of Canada will be a source of solar viewers, and other groups as well will have eclipse glasses. That's what we're working on. But just a note, if you still have those, take your students outside and get them to observe through it safely. Again, you just make sure they put it on before they look up, for example, and they will be able to see the sun through it. So if they're not scratched or anything, it's great to use them even when it's not a solar eclipse, because you get to see the disk of the sun. That's always very impressive for kids to be able to observe the sun directly. So use them even when it's not an eclipse, if you have them. They're usually, if you have some from past eclipses, if they're not scratched, they're still okay. Just make sure you check the filter to make sure it's fine. But usually that's, that can stay good for many years if you take care of them, or put them in the book, for example, and they'll stay good for the next eclipse. Oh yes, and I want to finish with this activity. Make your own Milky Way. I kind of forgot about this one. This is part of a module that's called Astro Arts, which will be coming out soon on our website. But again, I put the link there to the activity. This is, so Astro Arts is going to be many activities which connect obviously astronomy and the arts. And we try to have different activities with different styles of methods, artistic methods. And this one uses land art. So you go outside and you create a model of our Milky Way using natural elements in your schoolyard or nearby park. It's a great activity to do in the fall when you have a lot of leaves or branches on the floor. And it was inspired by this amazing galaxy garden created by the artist John Lomberg. This is a model of our Milky Way as a garden. Now, we don't expect kids to do anything like this, as amazing as this. And this is not something, this is something that stays there. What your students will make will be destroyed pretty quickly afterwards with the wind and the rain and so on. But what's interesting, and our goal with this activity is for them to understand a bit, what is a galaxy, the Milky Way galaxy, and the shape of it, or what's in it, and also where our solar system is. And for us, that's a big goal, because very often students will, or actually not just students, but people who are less aware of astronomy, they tend to confuse solar system and galaxy. And again, if that's the case for you, I'm not judging you at all, because it's really hard to understand the difference between the two. So this is really a goal for this activity, to differentiate what the solar system is and what a galaxy is. So understanding our place within the solar system and then within the galaxy. So that's why we say here, like, understanding our place in the universe, our cosmic address, in a sense, like to be able to say, this is our galaxy and this is what a solar system would be, but we don't see it on this scale. We tested this activity last year, and you can see some of the results here, and it was fantastic. Like it worked really well. It was beautiful. We did it in the fall, or was it last year, 2 years ago? And some schools were, more in the city, so they had more leaves, but not so much other material. And we had a team in Eastern Quebec, and they went on the shores of the St. Lawrence River right next to their school, and they had shells and rocks and big pieces of wood that they picked up right on the beach to create their galaxies. So it was very interesting to see the different elements that they use. So anyway, the description is here if you want to do this, and we'll be posting it online soon, but you get a sneak peek as at it with that link there. So this is what I wanted to share with you. Many activities to bring your students outside, different types of activities that you can do, either observing or creating models or even arts with that. So this is the sort of the end of my presentation. But I would like, if some of you would like to share some reasons. What are your reasons? Do you go outdoors with your students? What are some of the challenges that you face? Or anything you want to share with us, like other activities or things that worked well or things that didn't. You know, sometimes we try something, doesn't work so well, but we adapt and then we do better. But if you wanted to share some content like that, I would be happy to take your comments. Or if you're watching the recording, don't hesitate to write to me. It's always interesting to hear from you and get your questions or feedback from this. So if you have, if you want to share something, again, don't hesitate to contact us. I just noticed that the address at the bottom looked kind of weird, but anyway, we are on YouTube. We're also on Facebook and Twitter, where you can follow us, and you can see, if you write at info@Discover the Universe, it comes to me. So I'll see that pretty easily. So I think I will stop here for the recorded part of the webinar. And for those of you who are online, if you have questions, or I could even give you access to the microphone if you want to ask your questions, or you can type them in the chat or ask me questions. But if you have to go, or for those of you recording, for the watching the recording, thanks for staying till the end. And we hope to see you in other programs.